All right, let's see. You know an electron's position is plus or minus 0.78, right? So for this, we're going to say delta x is 2 times 0.78 times 10 to the minus 9th. Because I remember notice that that's nanometers, right? So let's figure that out. 2 times 0.78. Remember, you use the whole range. If they say plus or minus, the whole range is what you put in there. 0.78 times 10 to the minus 9th. And that is 1.56 times 10 to the minus 9th meters, right? So we're going to plug that in for this guy, right? And then we'll solve for the uncertainty of the velocity. I'll show you. So let's see. Let's figure out the uncertainty of the momentum first. So we're going to say 1.56 times 10 to the minus 9th times the uncertainty of momentum is equal to Planck's constant, 6.626, 10 to the minus 34th over 4 pi. All right, so let's do this. 6.626 e minus 34 divided by 4 divided by pi divided by the answer I just got. Okay, there it is. Okay, so the uncertainty of the momentum of this poor thing is equal to 3.38 times 10 to the minus 26th kilogram meters per second. And that, of course, is equal to m times the uncertainty of the velocity. So 9.11 times 10 to the minus 31st times the uncertainty of the velocity, right? Okay, so I guess I divide the number I just got by the mass, divided by 9.11 e minus 31. And I get that the range of uncertainty is equal to 37102 meters per second. I think we only have 2 sig figs, right? So let's see. 1, 2, 3, 4. So 3.7 times 10 to the 4th meters per second is the overall range of uncertainty. Now, if you had to say plus or minus, you'd have to say plus or minus, divide that by 2, right? Plus or minus 1.85 times 10 to the 4th meters per second. That's the total range. Ta-da! Yeah. If you say yeah, I think I already said that. Okay.